So in this video we're going to continue looking at the parabola and its different forms. We've already looked at this vertex form right here, or the standard form, and the main thing to know there is that wherever my vertex is, I can always write that as x minus h squared plus k. So if my vertex is at -2, -3, I get an x minus -2 or x plus 2 quantity squared, and then minus 3. That doesn't tell us about the a in front though, so we'll investigate a little bit more about the a that's right here. Okay, so a has a nice property in terms of which way our graph opens, up or down. So if I make a fairly large, a is 5, that makes my graph a lot steeper. The closer that is to 0, the more wider this graph becomes. So if a is 0.1, we notice it's pretty wide. A is 0 is not considered a parabola. Your x squared is gone, and so really that's just a line that's right there. We're not going to use those at all. But if a is negative, then notice what happens. Now my parabola is upside down. So a, the further it gets from 0, the steeper it becomes. So if I go to -5, notice, okay, it's still steep, but it's just heading down this time. Another thing to notice is that no matter what, so let me go ahead and put this at 0, 0 again. No matter what, 1 unit away from my vertex is always going to give me that a value. So you'll notice right here my x is 0, y is 0. If I go -1 or 1 unit to the left or right, my y value is now just that a, 1.7. Anytime I change that, say I put it at 3, y value is at 3. So what this does is just stretch the graph by that multiple of 3 right there. If I want to move that h or k value, it doesn't matter where I put it. Notice that wherever that vertex is, okay, so in this case the 3 would give me the vertex, so 3, -4. If I just go 1 unit left or right of that, I get these repeat values that are 3 higher, so at -1 instead of -4. So with both of those, this a just tells you how far over to go for the 1 unit away. It does get steeper after that, so it's not a line. You can't call it a slope or anything, but it just tells you, gives you approximate values of how steep to make this in terms of the parabola. Another thing to notice is the equation over here. So the expanded form that's over here, 3x squared minus 18x plus 23. Notice the a value. The 3, same a as this one. If I move this over, okay, a is 0.9, same a as this one. So the a value does not change between the general form and the standard form. Those a's are always going to be the same. So anytime I'm looking at this, really to get from the standard form to the general, I just have to FOIL this square out and then combine terms. That'll get me something like this. If I want to go reversed, say from something like this, we'll make something a little bit easier. Let's say -1. So -x squared plus 6x minus 13. If I want to get to that, to standard form, then I got to do something like completing the square. Okay, so I'd factor a negative out of both of those, take half, complete the square inside. So we're not going to go through all the steps in this video, but it's basically just completing the square on this section of the formula that gives me this vertex form. Another nice property to know is that the vertex in this general form is always at -b over 2a. So notice in this one, -b would be -6 over 2 times -1. That gives me the 3. That is my h value. Okay, so this -b over 2a always gives me the h that I can put into my vertex, so the x minus 3 for the square term. And then the k I get just by plugging in that x. So if I plug in that 3, -3 squared plus 6 times 3 minus 13, evaluate that all the way out, I should get this k value of -4. Okay, so -9 plus 18 is 9, minus 13 is the -4. So just plugging in that x will give you the k value that's right there. This makes it a quick way to get from this general to standard form. The h is -b over 2a. Plug that in to get my k. The a's always stay the same. So just some nice properties to know about those.